This food voting app is coming along nicely, supporting a reactive programming model through TanStack DB. If you're new here, welcome. Check out part 1 of this video to better understand the front end and what TanStack DB does. To evolve our app from front end only to one that supports a back end, we're going to need something that supports synchronization. Something that broadcasts changes to all users. Presented at ElectricSQL 2025, Phoenix.Sync is one of these libraries, wrapping ElectricSQL and broadcasting updates from the Postgres database to our users. As a word of warning, and I really hope this doesn't turn out to be true, this library feels like it's not a high priority for Electric. It hasn't been updated in a few months and has some outstanding issues. I might revisit the back end of this application using a different technology, but I wanted to wrap up part 2 as promised. Last time, we left off with the inner and outer loops of synchronization, where optimistic state stayed in React and persistence, if we can even call it that, happened in browser local storage. This time, we're going to swap out that local storage for an Elixir backend. Just like last time, TanStack DB will emit mutations whenever a transaction is completed. But unlike before, we'll have an opportunity to introduce business logic, authorization, validation, locking votes when a session is over, and if the backend is okay with the mutation, it writes to the database. ElectricSQL then watches everything that changes in the database and lets you stream it back to the browser through a concept called shapes. These are slices of the database consisting of data from a single table. They're the backend equivalent of the collections we established on the front end. Now, when I was designing this application, I came up with a data model that seemed very reasonable, the way I design most session-based systems. Users can create and therefore own sessions. Each session has many options, which may have many votes. Users who didn't create the session can join as participants, with votes tied to each of those participants. With structures like this, the list of sessions visible to a user includes the sessions they created, along with the sessions where they're a participant. This would have made it easy to pull all of the user's data and continue filtering solely in the front end. The problem with this is that currently, ElectricSQL and Phoenix.Sync only support filtering directly on a table. No join statements are allowed. And I know this is being worked on, but as of version 0.6 of Phoenix.Sync, it isn't available. So I opted for something slightly simpler, something that can work around this single table limitation. A user can view all of their own sessions, and votes are directly associated with users. By having the ID of a session, you're allowed to read it and its contents. It's not quite as magical, but it'll work. So let's get the backend up and running. You should be able to follow along with the GitHub repo, link in the description. Now, as I noted in this repo, the front end was just for part 1 and used local storage, but the full stack scenario ends up requiring a Postgres database that has write-ahead logging enabled. This is the way that ElectricSQL and therefore Phoenix.Sync can be aware of the things that happen in the database. You can either start this with Docker using the Docker compose file that's included in the project, or you can follow the documentation on Postgres in order to configure the write-ahead log. So I'll switch over to the codebase and pull up a file called mix.exs. And scrolling down to all of the dependencies, I have Electric and Phoenix.Sync. Now, I am pinning to specifically 0.6.0. There may be a newer version by the time you come across this video. Whenever you add new dependencies in Elixir, you need to run mix deps.get in order to pull those down and make sure that the lock file is updated. Then run mix setup in order to run the database migrations and seed the database with users and sessions following everything that is in seeds.exs. You probably don't need to be aware of exactly how this works, but just know the database is not going to be empty when we start. Now Phoenix.Sync needs to know how it's running and where it can access the database. In Elixir apps, databases tend to use a library called Ecto. This follows the repository pattern where a repo acts as a central location where all queries are actually performed. So over in config.exs, I'm going to drop a little configuration for the Phoenix.Sync library, letting it know that we're running with an embedded ElectricSQL instance and that our database is accessible through foodcaptain.repo. Finally, we have to configure our endpoint to know about Phoenix.Sync. And all of this, remember, is just a one-time setup for a project. We won't have to go through this again. So in application.ex, which is where the supervision tree and all of the sub-processes of an application run, I'm just going to replace this endpoint with one that is configured with the Phoenix.Sync library. And with all of that in place, I should be able to start the server with iex-s mix phoenix.server. And looking at this log output, all of this info level stuff, it looks like ElectricSQL was able to set up a replication stream and is watching the Postgres database. If you get an error here, your application's probably not going to work as expected. Make sure that write-ahead logging is enabled and that your config is pointing to the right database instance. And now we're ready to set up our first shape. As I mentioned, the database schema of this application has a few tables, and the most important of those is session. The session table is defined by a schema that includes a name, the state of the session, whether it's open or closed, the user ID of who created it, and some timestamps, along with the knowledge of an association to the options and votes. And the Phoenix.Sync.Router module gives us a very easy on-ramp to expose some of these database tables in their entirety over the network. So all that we have to do is set up a sync at a certain endpoint and point it to a module, maybe with some simple filtering. So let's give it a try. Over in the router file, where every endpoint is defined, I'm going to import Phoenix.Sync.Router. And this will make it so that all of the methods available on the router module can be declared inline inside of this file. And now, inside of the API scope, under the /API prefix, I should be able to reference sync, and let's call this /shapes/sessions. And this is going to expose the foodcaptain.sessions.session database table and associated schema module. And technically, that's all we need to do in order to set up a real-time subscribable stream of the contents of this database table that can be scooped up by the front end. To manually test this, we can go over to our web browser and just open up that API/shapes/sessions with an offset of -1. That -1 indicates that we want to pull down the data since the beginning of time. We want to make sure that we have every entry that's in the database. And the seed data that included the team lunch vote does show up in here, which means that we did properly expose that information over this API. So that little bit of validation helps us know that we're on the right track. Let's actually sync the data into the front end. Over in the project, I'm going to go over to where the front end lives, which is assets/JS, and let's pull up collections.ts. If you recall from last time, we used the localStorage collection options constructor in order to define the collections that are then used for queries throughout the application. And instead of using this, let's try out the electric alternative. So I'm going to replace this definition of the sessions collection with one that uses the electric collection options. I'll make sure to import that from the package. And notice that this uses a getKey function, just like the other collection, and it has the ability to support a schema. Now, unlike local storage, it does take a shape options object that defines where we can find our information. In here, we need to specify a URL where we can find the data, and one thing that it unfortunately requires is a fully qualified URL, hostname and all. I added a tiny helper to resolve a relative URL so it's easier to work with. That way we don't have to type localhost and then change it when we get to production. The helper is really just pretty trivial. And now if I open up the application, I'll see the empty state. But that makes sense. I'm filtering to only show sessions that are owned by the current user. Let's go over to that view to just remind ourselves. Yeah, we have this where session user ID is the current user ID. I'll remove that for right now and go back to the application, and there's our team lunch vote. And since the sessions list view and the detail view use the same collection reference, I can also open up the session and it'll work as well. And the coolest part is that if I open up the database and manually update the session's name, it'll immediately update over in the application because of the subscription that we established. Think of how much code and effort would normally go into that kind of synchronization, and then remind yourself all we had to do was reference an endpoint and define it pointing at a database table. Anyway, I think that's pretty cool. So back in the application, if I go and create a new session, and let's just call it test, I'll get an error in the console, which is that collection.insert was called directly, but there was no onInsert handler configured. You see, we were spoiled by the localStorage collection because it knew exactly how to perform writes. With the ElectricSQL adapter, we need to show it how to save data because it'll be different depending on your application. Since it's able to watch the database, we just need to write an endpoint that inserts a session into Postgres. And you might expect this to take place in mutations.ts, which is where a lot of our advanced writes occurred in the previous iteration of this application. The thing is, mutations that happen outside of transactions are defined directly on the collections themselves. This shields simple apps from the complexity of manual transactions until they're necessary. So we'll play along and start out simple, and then you'll see the way it evolves as we work through the rest of our writes. So I'm going to define a onInsert handler that's just going to log out the information that we would be working with so we can better understand what the API is going to need to accept. And by throwing an error, we'll automatically roll back the insert with no harm done. So back in the application, let's create a new session, call it test, and we logged it out, but the session only showed up for just a moment. And now we've got a transaction object. Transaction objects contain a mutations array, and the mutations array is where you'll find the information like that this was a insert operation, and the changes included the name of test, the state of open, inserted and updated timestamps, all the information that would otherwise have been stored in the local storage database. So let's write an API method to accept these changes and write to the database. The simplest way to do this is to start with a route that doesn't even return anything, but it accepts the information. Over on the back end, let's create a new controller, and we'll call it sessionscontroller.ex. Its implementation is going to be very simple. What we do is we define a create function that takes in some data and then goes to our sessions context to create a session. That's where we're going to write to the database. And then at the end, if everything is okay, we'll return a 204 no content response. Create session requires something called a scope, which represents the currently signed in user. If we dig in further, this scope gets passed into a change set. Change sets are how we define database interactions in Elixir, and they're kind of like a combination of validations and assignment. So what we've got in this case is we say the name and the state are things that can come from the provided attributes, and we require a name. Then we grab the user ID from that scope through a different object that's not directly controlled by the request body. That way somebody can't just impersonate another user. If you want to learn more about Ecto and change sets, take a look at my series called Phoenix Live View from Scratch, where I use it heavily. Anyway, all of our code going forward is going to assume that we're signed in. You might have noticed the register and login buttons at the top right of the app. This all comes from the Phoenix auth generator, and we'll be using it for the remainder of the project. So let's handle users over in our router. As hinted by the code that's commented out, we can easily require an authenticated user in different scopes of the application. So let's require a user on /app and on any API interactions. Now, when I open up the application, I get redirected to the login page. There was a controversial choice to default to passwordless magic link login in recent versions of Phoenix. I'll embrace it for now as I sign up for an account. And since I'm running on a local server, I can have a fake mailbox where I can click on a registration link and confirm my sign-in. And now everything works again. I am successfully authenticated as ca@example.com. Finally, we need to pass the current user ID to the front end, something that was hard-coded in the first video. So over in our app template, I'm just going to remove this placeholder and instead use that current scope user ID. Now, this isn't a security control. This is just an advisory thing to say what the user ID is so that we can hide certain UI elements that would only be available to the owner of a session. Getting back on track, let's define that create route, which is going to be a post to the /sessions, which is underneath /API. We're referring to the sessions controller's create method. And since it's in an authenticated scope, we're guaranteed to have a user. So let's wire up that on insert call on the front end. Over in collections.ts, instead of just logging to the console and throwing an error, let's do something a little bit more complicated. So we're going to do a post to this API sessions route, which is going to have a content type of application JSON. The body is going to be an object where the data is the changes from that mutation. And if this doesn't succeed, we're going to say failed to save the session. And if it does succeed, we're going to return everything successfully happened. I'll go back to the front end, insert test, and it showed up and disappeared again. Let's take a look at the network tab to see what happens. It looks like we got a 403. And looking at the response, we had an invalid cross-site request forgery token, or CSRF token. Now, I expected this as well, and again, I'm trying to show you all of the roadblocks that you might run into if you're trying to do this from scratch, but keep in mind that most of these hurdles only exist once until you've established a pattern, and then after that point, it's pretty productive and easy to extend this application interface. So by default, Phoenix APIs have protection for CSRF. When we make post, patch, and delete any write operation, we also have to pass this XCSRF token header. This prevents a type of attack where someone evil can cause you to unintentionally perform some write action from another site. That's why it's called a cross-site request. So we'll add a token header, and this just comes from that utils thing, and it's in our pages HTML. It comes with every Phoenix app, and all you have to do is set the CSRF token to that value. Again, it just comes from a meta tag on the page. So finally, we should be able to create a session. I'll close this out with some confidence. And let's call this one lunch. If I go over to another tab that's signed in as the same user, there's our lunch. So we can create a session on the front end. It optimistically is inserted into TanStack DB. Then we call the backend to have it persisted in the database. Once it's in the database, the change is broadcasted to all subscribers and reconciled in that front end. And now that a user can create a session of their own, we should address a scoping issue. The thing is, we shouldn't be syncing down data from all users in the app. It's a terrible security thing, and it's really inefficient if this app ever takes off. That sync that we added to the router is an easy on-ramp, but in real life, you'll probably use a controller to pull down scoped data. Much like the controller that we use to create sessions, the shape controller is going to contain functions that get wired up to routes. For our initial implementation, we're going to import the Phoenix.Sync controller module, which contains some utility methods that'll be really helpful for us in a moment. Now, I created a function that constructs a query over in the sessions context. Looking at it, it just takes that session table and filters it down such that it is only returning the items that are owned by the user from the provided scope. Then, and here's the Phoenix.Sync part, we just pass that query and the connection as well as any query parameters that were available on the request into the sync render function, and this will establish the ElectricSQL subscription and support all of the offsets and everything that we need for this GET request to be a proper shape. And now over in our router, all that we have to do is replace the sync call with a GET to that controller method. We'll pull that out, and if I go over to my browser, now I only see the session that is owned by my user. We don't see that team meal because it doesn't belong to me. Like I mentioned before, there are some limits on the types of queries that can become synchronized responses. There's some plans for Electric to extend this, but it's not in Phoenix.Sync yet. But that's not going to stop us from wiring up Food Captain. The current configuration works well for the owner of a session, where you can open up the details view, and that's just fine. But when I'm signed in as another user, the session is not found. But I think if somebody has gone to the lengths of having the UUID of a session, we should let them participate. To pull this off, I'm going to add another shape that returns a single session by ID. Don't worry, it's still live and will still broadcast all of its updates. It's just going to be another path to get to data from our database. It's our business logic. So over in Shape Controller, I'm going to add a new method that allows us to get a session given an ID. And that query behind the scenes is just where the ID is the provided identifier. No consideration for user scope. We're using UUIDs. They're very hard to guess. And that's just a decision that I made in this project. Then over in our router, let's just duplicate this, reference the ID, and call the session method. And back on the front end side, I'm going to introduce a new collection, but it's going to have a twist to it. Unlike other collections, this one is exposed as a function that returns a collection that is bound to a session by ID. Over in our session details view, we should be able to use this in order to grab the session. So I'll declare session collection to be a single session collection based on the provided session ID. Then I'll remove this sessions collection import since we're not going to use it anymore. And in our query, let's just pull in session collection. We also don't need this where clause because the session collection is naturally scoped down to a single session. Now, if we were to ship this code as is, every single time the component renders, we would get a new instance of that single session collection. And that probably wouldn't work so well. So what we're going to do is wrap this in a React hook called useMemo. This makes sure that we cache the value that is returned and only update it if a new, in this case, session ID is provided. So now, for a given session ID, we will only create this collection once, and we'll keep that for the lifetime of this view. And if somebody navigates to a different session, then we'll create a new subscription. And now over in my browser, as the other user, I can access this session, even though it wouldn't normally show up in my index. Now let's move on to the restaurant options. We'll do the same thing that we did with sessions, but with a twist for the mutations. So on the back end, over in Shape Controller, we'll add session options, which given the ID of a session, will return the options associated with that session ID. Then we'll wire it up in our router. This is all starting to become nice and predictable and boring. So now shapes, sessions, ID, options will hit the shape controller's session options method. Over on the front end, we'll add a session options collection function that takes in that ID and similarly binds to that ID as a collection. The options collection was directly imported in our options management component, so I'll replace it with a memoized version just like we did before, and remove that old reference. I'll pull in all of these imports, and everything should work just fine. Now if I go over to the browser and create a new restaurant, we'll call it test, click save, it disappears. Again, this is an indication in TanStack DB that something wasn't routed or handled properly. Now, if you recall from the first video, the way that we create session options is through transactions. These are explicitly created in the mutations file. And right now what we're doing is just relying on the existing localStorage accept mutations function. Now, first off, this isn't even the right collection. And secondly, this isn't how we would create an option. We'll come back to this in just a moment, but we need to go over to the back end and create a handler that lets us create options. So over in options controller, which is currently an empty stub, I'll paste in an implementation and let's walk through it. What we do is we look up a session to make sure it exists. And then if it does exist, we create an option in it. And that's just going to defer over to a change set method, and we just need a name, and then we take in the session ID from another parameter. It's simple enough, and we can wire it up over in our router. So I'll paste it in, sessions, session ID / options. When that's a post, we go to the options controller and call that method. Over in the collections file on the front end, I could just copy this utility function, but that would get pretty messy. Instead, I think we can extract this into something that's a little bit more reusable. So I'll just paste this in above our collection, and we can talk through what this does. I'll resolve some imports so we have the right data types. Okay, so if we want a reusable function that lets us insert or post a resource, we can take in that resource name and then have that parameterized for which endpoint we're going to call. And when we take in a transaction, we don't actually care about the table that it goes in. We just want to grab the changes from the mutation. This refactor actually makes our sessions collection thing look really nice, because all we have to do is say create API insert function for sessions. It's a nice clean refactor that we can use over in our options collection as well. And we just say sessions ID options is the resource that we would post. Now, over in our mutations file, we can replace our existing mutation function with a reference to this insert function, and we'll need to take in a session ID when we're constructing this transaction, and this will just be a string. Then we can remove the old one, and we'll have to clean up where we establish this. What this means is that we can create a manual transaction with a session in mind. And then when it commits, we're going to call the sessions, session ID options post route and provide whatever change is inside of that transaction directly to the backend. As we establish patterns and conventions like this within a project, we're able to keep the code nice and dry. So let's go to everywhere that we create a session option transaction, which should just be 2 places in options management. And right now we've got an error. We can just add the session ID. And now everything should be nice and happy. So I'll go over to my multi-browser window session. And if I create a restaurant over here, we'll call it test. It'll automatically hit the backend, save, and then get synced over to the other tab. Everything's working as expected again. And now that we can create options, let's support editing. Because if I go in here and call this tester, it will fail to save the option. And the reason for that is that we don't have an update handler on the collection. So if I go over to the collection, I can add something just like on insert, but it'll be for updates. Just like last time, I want to take a look at what's passed into this onUpdate function. So I'm going to start it out with a console log of that input. So I'll go over to the browser window, and with my console open, let's change this one's name to tester, hit save, and well, this one actually confused me a lot when I first wired it up. See, our Zod schema validates anytime we perform a write. That was one of the really big benefits from the initial write of this application. But it turns out that Electric returns date times in the format that they're stored in the database. In the network tab, if I take a look at a session's options, the value is this format right here, which is not an ISO timestamp. It is year, month, date, space, and then the time. So when we try to do a write, it's actually these values that are being processed incorrectly. When we try and save an object, Zod is saying you have an invalid inserted at and you have an invalid updated at. So another one-time thing that you'll need to do in this type of application, if you want this level of schema validation, is adding a custom parser, but it's not as scary as it sounds. Up at the top of my collections file, I'm going to add this object called a parser. And basically what this is given a specific backend data type, how do we turn that into something local to the application? And what I want to do is turn our integers into integers. This is required because Electric uses byte arrays instead of numbers for certain numeric values. I am not so worried about that. The one that I am concerned about is timestamps. And so what I want to do is parse the timestamp by adding the letter Z at the end, indicating that it's UTC, and then turn that into an ISO string at the end. This parser value can be added to any of these shape options objects, and you'll see it in them going forward. Let's add them to our sessions and to our options. And now if I go into my console and try and update this, I'll get a console log of what is being submitted. In this case, we have a transaction with mutations, and the mutation is of type update. It contains the original, the modified, and the changes. We can use these values on the back end, so let's add a controller to accept this. Over in that options controller, in addition to our create, let's add an update, which given an ID of a option and the data, we're going to look up that option, make sure that it exists, and if it does exist, we'll go and update that option. Again, this just defers to a change set, but calls repo update instead of repo.insert. Just like before, it's easy to add this over to our router, and instead of being a post, this one is a patch to an option by ID. Now, I'll paste in a function that is pretty similar to our create API insert function, and it's going to be for updates, which given a resource allows us to take in a transaction, hit a patch route, and instead of just calling the resource directly, we grab the key from that mutation. That's the ID of the option in this case. Then we pass in that data, which is going to be the changes from the mutation. And if it fails, we say that it failed to update. Now down in the options, I'll just change this over to update, update, and now this should work. I'll open that side-by-side view again, close out this console clutter, and if I edit this, it'll synchronize across tabs very quickly. Now, I have one more issue with the options before we move over to voting, and that is when I create a new session and then add demo options, only the first one gets written. That's because the way the demo restaurants button was wired up actually creates a transaction that has multiple inserts, and then it commits it all at the end. But if we go into the mutations function, it's calling our API insert mutation, which only takes the first mutation, that 0 index mutation. To fix this, let's change the backend to accept a list of restaurants. So over in options controller, when we're doing a create, instead of creating a single session option, there's another function just below it that'll take a list of attributes called create session options. This one will create a single database transaction on the backend and orchestrate a multi-insert. We'll come back to these Ecto Multi things later when we're looking at votes, but all you need to know is this function takes in multiple attributes and will create them in a single transaction. So I'll add the letter S here, and if data was just a single object, I would wrap this in the square brackets to turn it into a list. But we should support either a single data point or multiple data points. In Elixir, it's common to do what's called shadowing of a variable, where you redefine a name when you do something to it. So what I'm going to do is, if the input was a list, then we're just going to set data to what it was before. And if it wasn't a list, meaning if it was a single object, we're going to do that wrapping. Then we'll pass it over to our create session options. What this means is that if I go in and do a regular create without having changed the front end, it will save as expected. But if I want to insert more than one, all I have to do is make data into an array. In JavaScript, we can do this mapping by using a map operation where mutations is an array, and for each item of that array, let's just grab the changes underneath it. But to make it so that we're compatible with the rest of the handlers that haven't yet been updated to support bulk, if we only have one mutation, data is just going to be a single object. Then finally, when we pass it to the API, we're just going to pass the JSON stringified object containing that data key and then whatever value we establish above. So when we have one change, it's just going to be the object. And if we have more than one change, then we will map over them and make sure that we grab every single insert in the transaction. So if I go into the application and create a session called demo, then in that demo, I add demo restaurants. Actually, let's make sure that we're watching the network tab here. Add demo restaurants is going to add all 5 of these at the same time. And over in the network, the payload contained data, which was that array as expected. The other cool part is because ElectricSQL is watching the replication log, all of these inserts will come in through a single response because the database committed them all at the same time. Over on the vote side, we're still using the localStorage collection. That's why we don't have any options yet. It's easy enough to replace that with the new server-backed session options collection. Over in our hooks, voting.ts is the final import of our old options collection. Let's replace that with a reference to the new single session options collection. Pull those in. Get rid of the old, and we don't need to filter on session ID any longer. Now, if I go over to this application, go over to vote, we'll see all of the restaurants that we had from our options tab. We're reading from the same place, and that means that we get to go over to collections and finally get rid of the options collection. Good riddance. Now, let's get rid of our final local storage collection so that we're fully on the server by adding a new shape to the backend that holds all of the user's votes. So backend shape controller, one more time, we're going to add a my session votes. Given the ID of a session and given a user, this will return the votes belonging to that user. Then over in our router, just like before, we're going to add a get route for the votes. And it's going to point to that my session votes function on the shape controller. Now, this is going to be a collection that doesn't have an on insert or an on update of its own, because every time that we write votes, we do it through a mutation that has its own transaction. Now I will remove this reference, and again, we'll get back to this mutation function because the votes are a little bit more complicated. Now hopefully you can see the progression here. We started out with a simple insert, simple update, then manual transactions, and finally for votes, we're actually going to do an entire synchronization of writes and updates and deletes all in a single API call. I'm looking forward to it. Now back over in collections, this is now a function that takes a session ID, just like the other ones. So when we're wiring in this votes collection, we should do it the same way that we do with options, but we'll replace this with votes, session votes collection. And now everything should be fully server backed. Going through the voting hook, we've got insert operations, update operations, and even delete operations happening in the same transaction. For that, we're going to use one more Phoenix.Sync concept, which is the writer module. Instead of building a custom controller method for each operation, wouldn't it be nice to just send the whole transaction and have the backend figure it out? That's exactly what the writer does. We can opt models into writes, registering functions for loading the existing objects and validating those being written. Native to Elixir, this takes in Ecto changeset functions and performs its writes within a single backend database transaction. So over in our votes controller, I've got the scaffolding of what our controller method's going to look like. Given a list of operations and a session ID and the user scope, which we'll take a look at in a moment, we grab the session and return a 404 if the session isn't found. But the interesting part is what happens when a session is found. So what we're going to do is create a new writer and then pipe that writer, that is, pass that response type as the first argument of the next function, into writer.allow, and we want to allow writes to vote objects. When we're writing to vote objects and we want to load them so that we can figure out what the insert or the update operation is going to look like, we want to use a function that, given some attributes, will get the user vote for those attributes, considering the user scope, which we can fully define now. Get user vote will take in the ID of a vote and then return it belonging to that user, and it'll only return one of them. So now we can load in each of those users when we're updating, and when we're doing our writes, we're going to have a vote and some changes, and just like we would in any other Elixir context, we're going to construct a change set. So we're going to pass that to sessions.vote.changeSet with that vote, the changes, and that user scope. The vote change set says that a rank is required and it needs to be a number greater than or equal to 1. The user ID gets written and the option ID gets written. So I'll back out of this, and we've got one more thing to do. Once we've constructed this writer object, we've defined how it can be allowed to write, we need to actually perform that write. That's done with the writer.apply function, which takes in a writer. We're piping that in. It needs a database repo, and it needs a format. This is how it knows the structure of the inputs and how to apply those to be inserts or updates or deletes. And there's a specific format for TanStack DB. We are in luck. Now, this writer operation returns a 3-member tuple. If it's successful, it returns an OK. It also returns a Postgres database transaction ID and the changes that were performed, which we're going to just ignore with that underscore. This also means that we can have something to return to the front end. So rather than no content, let's pass a JSON response, a 200 response, with a transaction ID. This will help the front end reconcile the database operation because it's really complicated. And instead of looking at properties to figure out whether data that came from this save or from some other browser save, this transaction ID gives us something to bind to. Now, this code is all that we need in the controller to support a full insert, update, and delete with Phoenix.Sync. So we'll go over to the router and register this route. I'm going to use a put. So we are putting the votes to this update function. Now, back in our front end side, in the mutations.ts file, we are doing nothing with the transaction. I'm going to paste in some code and we can talk about it because honestly, this was the hardest part of the whole project to get right. So I'll replace this with a function that has a pretty complex mutation function. We'll get all of our imports in place and let's talk about it. So Phoenix.Sync's documentation implies that you can just send the transaction to your backend from a mutation function. The format thing that we set in the writer suggests that it knows how to read the transaction directly, but in practice, there were a few gaps. The first one is that TanStack DB transaction objects aren't directly JSON serializable. I assume that the structures were made more complicated until there ended up being circular references and other cruft that can't be thrown over the wire. But you can't just make the request with the transaction itself. You have to do some mapping of your own, which I'm doing in this example. So I go through all of the transactions and make sure that we capture the type, that is insert, update, or delete, the original, the modified, the changes, and then this sync metadata thing. I had to provide the table name, which is also known as the relation name, manually so the backend knew which object type I was trying to insert. Again, I think that this might have been moved around over time and just not kept up to date. Hard coding this sacrificed some reusability, but again, it allowed the system to work, and I think that we can figure out a pattern that's more generalizable as a project will scale. The good part is, once you have this pattern in place, it should be able to extend to any table type without much fuss. So we just have to update our voting.ts hook to create a transaction with a specific session in mind. Just like we do elsewhere in the application, we'll add that session ID and everything will calm down. Before I run this, there's actually two little mistakes in here. The first is that this change set requires a session ID to be passed in, and the second is that the apply function requires all of the mutations. So I'll pass in the operations as the second parameter. Okay, back to where we were. So if I go over into the application, into votes, and vote on a couple of restaurants and hit save, then those choices will be saved, and the request that I performed has a transaction ID in response, and its payload is a list of operations with an insert and another insert. Now, the really cool thing is I can hit up pasta place and move it up a rank, and then hit save, and now only the things that were modified are included in the updated request. So now we inserted one option and we updated the rank of the other one, which exactly matches what happened here. We inserted pasta place and then we moved Pizza Palace over to the third rank. This also ends up synchronizing across all of my tabs. So if I go into my votes over here, I can see those choices. And over on this side, go over to votes and there's the options. I'll move sushi spot down one and hit save, and it'll sync over to this side. Now, we could stop there, but we'd still have the same bug that we had in the first video. There isn't any validation on the vote ranks themselves. The whole app only works if we know that each user has one first place vote, one second place, and so on. By way of example, if I move this option into second place, and then on another tab create a new second place option, then hit save, now I have two second choices over here, and I would have the ability to save that to the backend. Nothing will prevent that, right? But behind the scenes, the Phoenix.Sync.Writer constructs an Ecto Multi, one of those structs that defines a set of database operations and callbacks to execute within a database transaction. Luckily, there is an escape hatch that allows us to add our own steps to the multi, including a final validation. So first, we can decompose this apply into two operations, transforming it to a multi, taking in the operations and a format, and then finally running the transaction. These two lines are functionally equivalent to this apply statement. This video is getting long enough, so this next part might be a little fast if you don't already know about Ecto Multi. I do have a video showing how they work, and the documentation is pretty good if that helps. Anyway, we'll add a multi-run call to run a function within the transaction. If it returns an error, the whole transaction will get rolled back. In this function, we'll grab all of the ranks of all of the votes, sorting by rank. This will give us a list of integers. Then it just takes a case statement, which is similar to a select in other languages, to check if all of the votes are sequential without duplicates. If there's no votes, that's okay. If we do have votes, we need to make sure that there's no duplicates and that they are sequential from 1, 2, 3, and so on. And that's it. Again, I know it was really dense. You can take a look at the code on GitHub and watch that video if you want to know more about multi. So now let's try and recreate that failure and see the validation in action. Over in the browser, if I move sushi spot into second place, but on another tab, create a new option called Pizza Palace also in second place, save that vote, and then take a look over here on the left, I have 2 second choices. But if I try and save those choices, it gets rejected and rolled back. We read from what is in the database on the back end, and everything is back in order. Now we don't have invalid votes. To tie this off with a bow, I think it's time to finally get the voting results. We only want to show the results when a session is closed. I'm going to quickly wire this one up. Over in our session details page, I'm going to add a new handler for when we want to close a session. That's going to take the session collection and perform an update setting the state to closed. When it's passed into the session header, it will cause a close button to show up for owners of open sessions. Continuing the speed run, over in our collections, on a single session collection, I can copy an update handler. And instead of updating an option, we are just updating the session object. Then on the back end, in the router, let's define that patch as the update method on the sessions controller. And finally, we can paste in a pretty familiar implementation. We make sure the session exists, and then if the user is the owner of the session, we update that session. And similar to what we did in the writer scenario, we're actually going to return this transaction ID and perform this in an explicit database transaction. Technically, we should be applying these access control checks and returning these transaction IDs everywhere that we're performing operations on the back end, but I'll leave that as a separate pull request on the repo for all of the stuff that happens after the video. Now, when I go into the session and hit this close session button, I'm taken to a results page with a 404. If you've been wondering how we're going to calculate the voting results, you might be surprised. All of this reactive state management and fancy synchronization is helpful when datasets are evolving and users are collaborating. But sometimes it's just not necessary. When a vote is closed, it's closed. And for that reason, I opted to add one more backend route. It just calculates the ranked choice results. Over in our votes controller, I'll add one more method. And this is going to call a ranked choice voting.calculate results function. This is actually something that's been sitting in the repo for a while and is fully tested. It goes through multiple rounds of ranked choice voting. If I look at the tests, we can see exactly how it's supposed to operate and the different scenarios that were considered during its implementation. All you need to know is that when a session is closed, we calculate the results, and this is going to be an endpoint that we can call from the front end. Let's wire it up in our router one last time. It's a get of the results, votes controller, ranked choice results. And to make this slightly more interesting than just having one person voting, I also added a simulator command to the repo. So let's grab a new session, seed it with some demo restaurants. Here's 5 of them. I'm going to grab this ID. Then over on the back end, I'm going to run a mix task. This is a custom script that I added to the project where if I run mix simulate votes, and we'll do 30 users, and we'll pass in our ID. Now this is going to create a bunch of users. It's going to have them vote randomly, a random number of times and on random options. And finally, if I close the session, I'll get the results. It looks like Sushi Spot is the winner. Here's the breakdown for every round of voting, who was eliminated, and in the end, it was 13 to 12, and we needed 13 for a majority. And that's the project. We were able to take a local storage prototype, wire it up to a synchronizing backend, and end up with a usable app. Obviously, there are still some rough edges in this library, and I have some questions about its long-term viability. But the good part is, TanStack DB is backend agnostic. In addition to the electric provider, tools like Trailbase, RxDB, and PowerSync can be wired into your applications with minimal code changes, similar to what we did today. And I'd really love to see a Supabase adapter, but we'll have to take them up on that some other time. There are a few other changes I didn't have time for in the video, like returning transaction IDs from all controller methods and respecting the closed state of a session when accepting rights to votes and options. If you're interested, there will be an additional pull request on the repo showing all of those improvements. As always, that'll be in a link in the description. This has been Code and Stuff. Thanks for watching.